interesting.
Thank you. Look, one question. Last speaker, just or anyone can jump in. Do you think the brain can be emulated on a Turing machine?
The short answer is yes, because I haven't seen any evidence of the opposite. The long answer is that I don't really know. Maybe not, but if not, then how does it actually happen in the brain? And if it can happen in some way in a mechanistic system such as our brain, then you would also be able to implement that in another substrate using a similar mechanism or emulating that substrate. It doesn't mean you have to go with a Turing machine. Maybe you need to use something fancier. I don't know. But the point being, if it works in the biology, why not somewhere else? What's so unique about the biology?
Just a quick functional sketch to that was the problem being that you may be able to simulate it to a degree of accuracy on a Turing machine, but yet it may be experientially different to the actual simulated AI than the one in vitro.
Okay, this is kind of like the qualia debate thing. Like, you know, is your red the same as my red? But the question that really occurs to me there is, how do I know that you are actually functioning just like I am? As in, how do I know that any of you are experiencing being the same way I am? If I build something that is a whole brain emulation, and it tells me, hey, I'm conscious and I feel like myself, I'm inclined to believe it, same as I'm inclined to believe you.
Anyone else respond to that? Another question?
I'm sorry, this is a question to Randal as well. Just a quick question. The cyber cell, you said it's not actually new technology or new knowledge. Could you tell me where that cyber cell is located? Is it in a petri dish or in a laboratory, or has it been injected into a human?
Okay, what I mean by it's not new technology is that all of the parts exist right up to the point where chips have been put inside cells and the cells continue functioning. But no one has actually put all the pieces together exactly like this, because otherwise I wouldn't have used rendering as I would put a photograph in.
Right.
Jaan, is that right? Jaan?
Yes.
Do you think it's technically possible to friendly program the very early AIs in such a way that even after they've self-modified themselves into a creature trillion times above human level, that they still remain human friendly? Do you think that's possible, or is that a kind of illusion?
Remain what? I think that given the humanity's knowledge right now, it's not possible. So that's why, like, when I presented that AGI space seems to be, or AI space seems to be like a target with a really dangerous area in the middle, and a tiny speck that seems that might be like benevolent towards us, and we don't have like a good idea how to aim for that spot. So we right now it's more practical. It seems to be to actually limit the AIs in some domain that would ensure that we have control at least until we figure out how to make that really precise shot. So that I agree with you that right now it's not possible. However, in principle, I don't see a reason why not. In principle, I think it is possible.
But isn't that the tail wagging the dog, in a sense?
Well, I think I agree with him that right now, given the precise level of knowledge we have today, no one knows how to sit down and program an AGI that will preserve its goal system to any approximation through recursive self-modification. I guess my view is that once we have a more solid theory of general intelligence, we will have a better answer to that question. And the route to a more solid theory of general intelligence is by building and experimenting with general intelligences rather than by doing kind of armchair philosophizing and theorizing. So I think we'll have a better answer to that once we build simpler AGI systems that do simple stuff and have made theories to help explain their behavior, and we have more science and engineering of AGI working together.
My view is that in the end, AGI is just a program. So it's like we give it a goal, like either explicitly or more likely, unfortunately, implicitly.
Well, you think
It
it's
will do
just,
something that we caused it to do.
but you think it's just a program in a sense that you are not just a program. So you think you have some kind of agency or autonomy that an AGI would never have.
I consider myself also a program. So.
Okay.
Okay.
Yeah, in that
A
sense. I
causal
agree.
system of a complex system of causally, what's the word? Causally influencing components.
Yeah, I have a follow-up question to Jaan actually, which is, so you mentioned that it would be good to stay outside of a certain sphere, keep some domains off limits. The question is, where do you draw the line? Because it seems like you could come up with scenarios where basically anything leads to dangerous AGI. And for instance, you said that we shouldn't be giving an AGI any insight into humans.
That was just an example.
But we have, for instance, AI, narrow AI, being used to mine DNA, things like that, which is a kind of insight into humans if it's human DNA.
Yeah, I think it's a pretty long step from DNA to actually where you could consider the motivations and start modeling actual
Well,
people with actual knowledge.
one of the projects that I'm working on with Chris Poulin, one of my colleagues in the audience here, is specifically using AGI to try to understand the emotions and motivations of some humans and try to predict their activities. So, I mean, this is stuff that AI is being used for right now.
Okay. I have thought about it, like what are the especially dangerous domains? And like two domains really stand out to me. They're politics and programming, for like obvious reasons. So if we could keep the AI out of those two domains, we are much safer. And Eliezer Yudkowsky has this saying in Oxford, the Intelligence Conference, where you were also there. There was this question like, what kind of signs should you look for in order to, as like early predictors of an AGI? And one sign was, Eliezer came up with was that the best chess program was written by a program. And that's like a situation where they get to programming.
Yeah, I see what you mean. I think that it's very difficult, though, to really draw the lines that you're going with saying programming, politics. Obviously, you understand that these are your first targets. You say politics, programming, but maybe there are a whole bunch of others, and it spreads like that. Plus, there's the issue when you say program that writes a program. Again, it's kind of a fuzzy line. It's like someone wrote a compiler that then compiled the program into something more efficient, which would then run. So
I'm not saying that it's easy to code enough those two areas. I'm just saying that if they get there, it's like pretty much game over. So it's like ideally we should code them off in something that's easier to control for us. Like I had the example of like virtual worlds, and actually design those virtual worlds in a way that they're easy, that they're hard to break out, and that make the AIs uninterested in breaking out. So like they would themselves observe that the developments that happen in those virtual worlds. And if they see something out of the ordinary, a glitch in the matrix, so to speak, they would basically not like it and consider that this world is doomed and shut themselves down.
Another question?
Another question.
So it seems that a lot of the advances in narrow AI have been a result of commercial imperatives, near-term, tangible rewards, right? A lot of allocation of resources, right? Rather than necessarily the interesting and fun problems being resolved. And so when we talk about GI, we haven't really talked much about how near-term commercial applications might shape that, or there might be benefits coming out of it in the 10-year horizon before we get to something more mature. Can we talk about that a little?
Yeah, better than mine. I mean, to address your first point, I think probably 80% of AI funding in history has been from the U.S. military, which is not necessarily commercial. And And while it has the disadvantage that it's largely focused on military pursuits, has had the advantage that it tends to be longer term in focus than most companies. It's certainly true that it's easier to get funding for things that will yield short-term commercial return, and so it's easier to get funding for AI for enhanced natural language search, like Google is doing, or AI for planning and scheduling and logistics, as the U.S. Army does, or AI for stock market prediction, AI for video game characters, like our project here in Hong Kong. And each of these AI projects has a little bit of spillover to help move toward general intelligence a little bit more in some cases than others. I think that to really progress really fast toward building thinking machines that can think like people and beyond, we really need a sustained, focused push on that problem. And I've come to the unfortunate conclusion, after years of trying, that to try to pursue general intelligence in a way that also optimizes some commercial goal along the way, just ultimately that's not going to work. It's not going to work very well. The commercial goal will require you to customize what you're doing along the way to that commercial goal, and there's always going to be some easier way to fiddle with what you're doing to make money and satisfy the customer requirements faster. That leads you away from what you would do to move toward general AI. I mean, I think you can do narrow AI that shares some code with the general AI, and you can do narrow AI to make money to fund general AI. But ultimately, you just got to bite the bullet and work on building a thinking machine if that's what you want to do. And so myself, I'm working on a number of projects, some of which are narrow AI, and then AGI as its own project also. I mean, having said that, I think once you get to the point of having an AGI system that has a basic common sense knowledge of the everyday human world, once you get there, and I think that has to be done by focused work on AGI itself, but once you get to that core, of course, a host of applications can be built on top of that, because pretty much anything that can be controlled by a computer could be controlled better by something with some common sense knowledge, from scientists to service robots to pretty much anything you can name.
As long as it's not politics or programming.
Programming can be done way better by AGIs than by people. People aren't very good programmers.
Yeah,
Politics is
I also think that programming will be the more likely bastion to fall.
I mean, politics is a different thing, of course, because that's all human emotion and negotiation and so on.
Yeah, but so are financial markets, and they have pretty much taken over those.
Hey, Mike.
All right,
Hey,
so we're
Mike,
gonna-
hold on. Mike, you were going to say something, Mike?
Yes.
My idea for the question is that if you have something that you are passionate about, you can contact us to try to put some intelligence into your application, so we don't have to worry about we don't care about what you're doing, but we can collaborate and then bring some funding into our project. So we think it's a good idea.
So we have time for one more quick question. I'm sorry that there's only time for one.
I think for general intelligence, when it comes down to the definition that you had on your slide earlier, is that it's really about modeling and being able to learn about situations that it hasn't seen before.
Yeah.
Now, whether this is not really the programming problem of editing or even the narrow AI, it's basically that's the one thing that we want to solve. And maybe the narrow initiatives, as they get more complex, if we're not solving them in the simpler ways where we need to create a more abstract model of whatever the problem is, we'll see that growing from there. If you want to talk about attacking that side of it, really the modeling, creating mental models of the world from scratch rather than feeding in a common sense database.
Well, I don't think hardly anyone is working on feeding in common sense databases anymore. That's really, that's psych and other obsolete approaches from the 70s and 80s. So I think pretty much everyone who is conceptualizing the work as AGI is working on learning systems and systems that gain either all or the vast bulk of their knowledge from their own experience, and implicitly or explicitly building up a model of the world from that experience. I think it's become fairly clear from mathematical work on the foundations of AGI that if you have a big enough computer, you can make a system that can basically optimize any computable reward function. So with a big enough computer, with enough memory and processing power, hook up the computer program to some sensors and actuators, give it some reward signal of some kind, something it wants to do, which could be getting you to push the good robot button, or it could be creating new things, experiencing novelty, whatever the reward function is. You have a big enough computer, it can learn to optimize any computable reward function. By learning, AGI is solved. The problem, of course, is we don't have a big enough computer. We're in a universe with bounded resources. And so we have to do some complex algorithmic and data structure work to make a system that can do reasonably robust learning from experience with bounded resources. Toward that end, you may want to explicitly supply the system with some inductive biases to guide its learning. But I don't think you want to go to the level of something like psych, where you're coding in knowledge, like a cat is an animal and a cat has a tail. I think the inductive biases you encode are more like, okay, for the perception module of the system, we will encode a hierarchical network, because hierarchy is an obvious pattern in, say, the visual and acoustic perceptual stream of the system. So you can make the visual system hierarchical rather than making it learn that vision should be a hierarchy. So there is some bias that you build in by the way you architect the system. But that bias is just to guide the system's learning from experience. What I think is the critical point is the system recognizing and modeling its own self as something that it perceives in its experience. So you can recognize patterns like this guy walks from here to there, you know, that at night the sun goes down. There's a lot of stuff you can model in the world. Once you can recognize your own self as an agent in your percepts and model yourself, then you can interpret the rest of the world as patterns in relation to yourself. Then you start to build out a whole self-other world model that you can interpret everything else in terms of. And then Bob's your uncle, you know?
Can I just make a quick comment? Ben, I think you're spot on there, because that n-order cybernetics, the second-order cybernetics is so essential to this. But if we follow the other dictum, the AI is no more than a monkey. And it's certainly, but it's going to be smart. And if you try to keep it dumbed down, that doesn't serve the purpose of creating AI or AGI in the first place. So that the biopolitics have to surface in there, because it's going to have a sense of its own morphology. So I think that you get yourself in a circle of disappointment, where alternatively, I think Ben's approach seems, they're both intelligent approaches, but it seems more logical in the sense that any AGI, any AI that's going to be bottom-up information and want to learn and continue growing and creating its own environment will want to program its environment just like we do. So it just makes sense. And I don't think we can keep friendly AI. And I mean, I think that even the concept of FAI is almost silly in regards to this, because friendliness is an emotion that comes and goes. How do we care who's friendly to us? It doesn't show a sincere, authentic efficacy of behavior, whereas empathy or a certain level of efficacy does. But I respect what you're saying, but I think the second order makes sense.
Two important points. Actually, the friendly AI, not a very good term, because it actually it has a technical meaning. It doesn't mean friendly as in humans are friendly.
Right.
And the other point is that sort of gets me out of the loop is that as opposed to a few people here, I don't see creating AGI as like a goal in itself. I think it's important what that AGI does. We shouldn't forget, like, the other more general view is that I'm a consequentialist in a view that I consider possible futures, and then see like whether I would want to live and whether I can live in one of those futures, and then only look at how does the AGI come into play. Like, does an AGI, and one particular AGI, make one of those nice futures more likely to happen or not? But I see, unfortunately, that in vast majority of cases, the AGI will just end up in a dystopian future where I would not want to live, could not want to live.
Okay, so we could keep talking about this for a while, but we're gonna shift gears for just a very short debate, a little more about AGI, and then we will be